This is a video showing how to determine the heart rate using a force platform. I've previously connected a force platform and a hand grip heart rate sensor to Capstone. I've created a graph with two graph areas, one for the heart rate and one for the normal force. When the heart beats and ejects blood from the left ventricle, that blood will go up and through the aortic arch. As that blood takes that corner, it will exert an upward force on the aortic arch and will reduce the normal force felt by the force platform. So using this information and the large negative extrema, we can determine the instantaneous heart rate between beats that are shown here. So we'll do that by zooming in on the area under a known heart rate. Now remember, the heart rate that's determined by the hand grip heart rate sensor is averaged over 5 seconds. The sampling rate on the force platform is much faster so that we can see these transients and determine when the blood is actually flowing through that aortic arch. So I'm going to go ahead and translate this over so that we can expand the graph in the area of this last data point. So can I expand things on the horizontal axis by clicking on the numeric values on the horizontal axis and stretching that out. The top and bottom part of this graph area are tied together so we can see the correspondence between the two. To expand the vertical axis on the bottom graph, again, grab on the numeric values and expand those out. I'm going to be looking for the spacing between these large negative deviations because that's when blood flow is occurring. To determine the values down here, I'm going to select this graph to be my active graph. Then I'm going to go up and select my Smart Tool. I'll go down and select Add Coordinates Delta Tool. That will give me a cursor that will allow me to select one of the minimum values that's around this value of known heart rate. Next, I'll right-click on this cursor and select Show Delta Tool. That will give me a second cursor that I can place on my next negative deviation here. So I'm given the difference between these two in time, which is 0.724 seconds. Generally, heart rate is reported out in beats per minute, so the conversion formula for that is to divide 60 by this value. When I do this, I determine a heart rate of 82.87 beats per minute, or essentially 83. To determine what my hand grip heart rate sensor says, and remember this is averaged over 5 seconds, I'll go ahead and make sure that I have my heart rate graph selected. I'll go up to my smart cursor and click on Add Coordinates Tool. And then I can move this over to my value over here, and I get a heart rate of 84 beats per minute, which is in good agreement with the values from my force platform.